Hey, what's up, guys? I just wanted to show you some ideas that I've been brainstorming here in 2D. But before I get to that, I wanted to tell you why I'm showing you some of these ideas. A couple of inventions I worked on in the past, one of them being this lawnmower. What this lawnmower does is it burns leaves and grass clippings as you're cutting the grass. You see there's a little cyclone combustion system on there, and I did all different types of combustion chambers and kind of tried, well, that's something different right there. But all these little different chambers I built to keep the leaves from flying out of there while the system was burning. And I got a lot of good information from these tests, especially from this one here, which pertains to you guys, is some cyclone burning. We don't have to do the cyclone, but a lot of the things that happened in these machines is definitely going to benefit you guys. For example, putting in some bottom air totally changed the game on burning piles of lumped up material that just wouldn't burn. And also having a grate in there. Another piece of equipment that is going to be used to validate some of the information I'm giving you guys is this forced air fireplace that I have. This is a very small fireplace, but it'll run you out of here. It gets so hot. And it's just made out of steel. And it has a small shell of refractory at the bottom of it, about that thick, and that's all. And it has massive fireballs in there constantly. Large piles of burning red hot coals. And it has not burnt through in the past 5 or 6 years, I think, that I've had this thing. So I wanted to talk to you guys about what we want to do about our firewalls. I guess we'll start at the bottom here. One of the ideas that I had you guys might want to consider is a removable ashtray. Essentially what we have right here is the 10-foot by 4-foot box that you were showing on your diagram. And this right here is a grate. Basically just a metal grate like you'd see in a fireplace, so that whatever we wanted to burn, say we throw a big old wooden box in there, would sit on top of that grate so that you constantly have air coming up from the bottom, and as coals and ash develop, they fall down into this big ashtray that we see right here. This is an ashtray that has a little hook on it that could be dragged out of the incinerator. It's sitting in here like this. You open that little side door, maybe you hook it to a tractor, and you just drag it out of the unit. The grate comes out with it. The grate is just sitting on a stand. This is just some cast iron bars. Here's like a side view. I guess that's not a very good representation, but it's just a table made out of cast iron bars, like a regular fireplace grate. We could mount this inside to where it doesn't come out with the ash box, but I highly recommend we do a side door also on the 4-foot side, right here. I had a 3D drawing for you guys, but I accidentally deleted it. So, oh, that's depressing. Don't worry about that. I'll get you another one. I like to think with this 2D software anyway, because I'm quicker at drawing. So I wanted to show you the door in 3D, but essentially that is how we would get all the ash and the bones and whatever pieces of metal that don't burn and stuff like that. We would just push it right back in there when we're done. It should be, you know, like a, I'm thinking an 1/8 inch steel box. Not 1/8 inch, I'm sorry. Yeah, 1/8 inch might be a good idea for something like this. You could probably get away with 16 gauge stainless. The reason I say stainless is because some of the liquids and slags and stuff like that are going to be highly corrosive. So if that's cost prohibitive, we could talk about the lifespan of steel. We could also use just the 16 gauge steel for this, but it might burn out over time if certain rules weren't followed. Now, as far as the refractory, the only zone we actually need refractory is about 8 to 12 inches high on the edges around the entire thing, because essentially what we would have there is like a coal bed would build up like this of red hot coals, and the only areas in the combustion zone that are in real danger is where the red hot coals would touch the sidewall. That happens quite a bit in this unit here, and it has yet to burn out. You can see it's got some warping there in the metal from some extreme metal fatigue and all that. But in our case, if we limited the refractory zone to just a 2-inch little firewall, 2 inches thick by 8 to 12 inches high, that wraps the entire thing like we see here. So that way when we get a coal bed going, these burners here would be able to handle that. This right here is what I think we ought to do with the burners. The burner that I have in mind for you, they updated on me, is this burner right here. This is, I'll send you a video on this burner. This uses compressed air and a blower at the same time, and I'll get into why there's a huge benefit to that. We can just run air half the time and not even need to use any fuel in certain situations when we're incinerating things. So, okay, so let's get into some options we have on the air input. The other option I was thinking of was we make the entire side panels out of a composite stainless steel about this thick, you know, a 2-inch thick panel that has ribs inside of it, and we make it like an air hockey table that's got a bunch of holes that are just punched in there with a plasma cutter. You know, nothing's, I don't know if you guys, I look like you guys had a plasma table. So what we could do here is every inch we put a 1/8 inch hole, and we turn this sidewall into a 2-inch or 1.5 inch plenum that has a blower connected to it, so it has air blowing out of those holes to give the fire some air, and that eliminates the need for insulation. But we would have ribs going through it. In addition to that, the other option was we could have one blower running the entire system. One blower connects to each burner, 2 burners, and we also have an air rail going through on both sides of the incinerator with holes in a tube. Like, let's say this here is a 4-inch pipe that runs down both sides. It would branch off on a T right here so that both sides of the incinerator has this air rail blowing air straight across, kind of at a downward angle, and kind of at an upward angle at 30 degrees. So shooting out 90 degrees, down 30, and up 30 is kind of little blaster blower air inputs there to help burn everything. So that's one idea that we could talk about. And these are just rough sketches of the idea. This is not by any means the finished product. This is just, we may totally modify either or. The good thing about this is it gets us out of needing any insulation, because the panels will be mostly cooled off by the air being blasted in there. And you could expect to see exterior temperatures in the 300 to 400 degree range, which is just barely enough to start feeling the heat off of it if we did that. And that would be a pretty good situation for us. So I could maybe do a couple of small tests looking into this to see, you know, how viable that is. So we would have these as, these burners also act as air blowers. They blow a significant amount of air on top of the flame. And the only reason why I decided to go with 2 of them is because of the size of this device. We could just add one burner on one side that's able to shoot a flame out all the way to the other end of this. That is very possible. It's just you don't want a lump of wet wood or material or something stuck on one side of the burner. The farmer may find himself wanting to burn some extremely green brush and tree limbs and stuff like that. And we want to be able to handle that. So that was just the thought behind that. And these are completely sealed. I have not got to the lid yet, but I do have some ideas and where my computer's acting hacked right when I need it to do the right stuff. So if we make the lid, the top curved like this, we could have the lid like do something like this maybe to open and close. I know it doesn't look very efficient here, But I had a 3D drawing that I deleted where this worked out pretty well as far as how easy it is to open and close it. And you don't have the danger of some big lid like up here on the top slamming down on somebody. That was my main worry. Is we could put a big old counterweight on there, no problem. But just to make it compact, I thought this was another idea we could look at, is a large hinge swing door. Something that kind of moves like this here to open and close. And I know some ways that we can get out of needing a counterweight to do this and it not be that heavy. I've got kind of some thoughts on that. But if you want me to take the time to draw a better version of this, I will. I'm just trying to give you guys some dinner napkin descriptions of what I can do for you before I get all into it. And we haven't even got to the cyclone yet, the cyclone separator. I'm sure you've seen these before. We would have something similar to this on the exterior of the unit. And what that would do, it could serve two purposes. It could be the afterburner, and it could also be what stops all the ashes and burning embers from flying out the top, like big chunks of burning paper that haven't quite, big flaming pieces of cardboard. We don't want flying out of the top of this. On your drawing here, you have it scaled about this size. I don't think we'll need to make it that big if we do it right. We can, if we just pump enough air into it, it won't need to be this big. We just kind of throw some trailer wheels on this thing and just make it a little trailer with a trailer wheel in the back there and a hitch coming off the front to connect to a pickup truck or a tractor, so that it can just be pulled around like any other farm implement that has wheels. Most farm implements have wheels where it can be toted around by a trailer. I'm not saying the fork idea is a bad idea. It is a good idea. We used to move things all over job sites with an all-terrain forklift, so I'm very familiar with the process. The problem is a lot of farmers don't have forks for their Bobcat. They just don't. Some do, a lot do, but I know a lot of guys who want a Bobcat and they do not have a set of forks, and they would not be able to easily move this thing around. So just, maybe look into the cost of maybe selling a version that has an axle on it too, so we can just hook it up to a truck and tote it around. And as far as dragging this box out of here with it lifted up off the ground like that, we could figure that out. We could figure out a way to make that easy. I can even help you guys out with control boxes and stuff. I build a lot of custom furnaces. This is what I'm working on right now. And this is the type of blower that you might consider running your system on because of how durable they are. This is an actual combustion blower, and I am very good at the electronics needed to run this kind of stuff. I don't know if I should show you inside here. It is kind of a rat's nest, but if you guys needed help, setting up a little control box, we could even make this thing, let's say you wanted to set it on 2 hours. So a farmer, sets it to run 2 hours, then he can walk away and go do what he's got to do, and he comes back and it shuts the fuel off in 2 hours. And then, but maybe we want the fuel to shut off for 2 hours, but we want the blower to stay on for 4 hours to burn up the bones and the rest of the ashes and stuff like that. That's also a very economical configuration because, as I said, you won't always need to run the fuel on an incinerator. As soon as everything's dried out, you're good to go on just air. You could just run the fuel for a very minimal amount of time. So that's just, I thought I'd show you this also, let you guys know what's going on here, and just kind of share these lab notes with you guys, because I've put quite a bit of work into incinerating yard waste and stuff like that. I've tried screens and everything, and these screens just clog up in seconds. The ash melts and clots onto the screen. Actually kind of protects it. It's an interesting thing. We might be able to use that to our advantage at some point. But at any rate, that's what I got, guys. I just wanted to show you that I do have some information in here about clumping and all different types of problems that I had making this lawnmower work. And I've got some other videos for you guys on a trash can size incinerator that I built that used forced air. So, and I do remember some of the clumping problems that I had there. And what I mean by clumping is sometimes you'll just get a large pile of material that just won't burn. It needs stoked and poked at with a stick. Like if you wanted to burn a big pile of wet books, it's just not going to happen very easily. You kind of got to prod at it and stuff like that. But I found that the grate can greatly eliminate the need of that problem, because it just lets it keeps that bottom air coming until the ash box is full, that is. So that's kind of what I got, guys. I could show you better details on what I mean by composite panel. This panel is 1.5 to 2 inches thick with stainless steel ribs inside of it. Actually, we could get away with putting some steel ribs on the inside of this probably. They have holes in them to allow air to blow through our little hockey puck pattern here. Or not hockey puck, but our air hockey table pattern. The air hockey table pattern, as I said, would eliminate the need for insulation inside. But I don't know how much I like this idea as far as performance goes. I think this would be the Ferrari of incinerators right here.